Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to continue with acid-base titration, and I'm going to work out a couple of problems involving titration. The first thing I want to kind of point out that I didn't point out in my last video is the distinction between endpoint and equivalence point. The equivalence point, as I wrote down, as I said, is the point at which the number of moles of the OH is equal to the number of moles of the H plus if we're doing an acid-base neutralization. So you have equal moles of H plus and OH that was added together to neutralize each other. That's the equivalence point. The end point is the point at which during your experiment, during the titration, you have a color change. And those points aren't defined in the same way, although they're supposed to be relatively close to each other. And that's the purpose of the indicator. So when you choose an indicator, the purpose of the indicator is to have the indicator change color at the equivalence point or very close to the equivalence point. So although in the experiment, we assume when you hit the endpoint, you're pretty much, we assume you're at the equivalence point and you have neutrality. But those two points are distinct as far as definition and the concept is concerned. Okay, so the first problem here is saying that you have a titration. So the titration of 10 mils of HCl solution of unknown concentration. So you have HCl. You have 10 mils, so you know the volume, and but you don't know the concentration. But you do the titration, and you find that when you do the titration, your burette has NaOH in it, and the molarity of the NaOH is 0.100 molar. So you're titrating by adding this NaOH solution to your HCl solution. And this requires 12.54 milliliters. So you put in 12.54 milliliters when the color changed. So you stopped at the color change and you measured the volume and you found, oh, I added 12.54 milliliters of my NaOH solution. And then you assume, okay, that's the equivalence point. And then this is asking, what is the concentration of the unknown HCl solution in molarity, moles per liter? Okay, so what you want to do is you got to start somewhere, and if they give us molarity, again, you don't want to use molarity as a starting point, but you're going to use it as a conversion. And so what you want also is a balanced equation. So in the balanced equation, the first thing you want to do, and I'll write it up here, is you write out the balanced equation of the reaction. So I'm taking HCl aqueous, and I'm reacting that with NaOH aqueous, and then you figure out the product. So the inner ones are going to go together. That's going to be your NaCl aqueous because that's soluble in water, and you have H and OH. That's going to go together and form water. H2 liquid. Okay, and so you make sure it's balanced. So you got your H and OH, that's in the water, that's balanced, and you got your 1Cl, 1 Na, so that's balanced. So this is your balanced equation. All the coefficients are 1. Okay, so we have our balanced equation. The second thing is you got to figure out where you're going to start. So it's saying, what is the concentration of the unknown HCl solution, so in moles per liter. So what you need to find is the number of moles of HCl. Okay, so we know that the mole ratio between HCl and NaOH is 1:1. So that's gonna be helpful. So we know the volume of our NaOH. So that's the only thing we're given. We know the volume of HCl, but we're going to use that later. So we're not going to start there because it's not going to get us anywhere because we don't know the concentration of HCl. So we can't convert the volume of HCl to moles, right? Because we don't know the molarity. But we do know the volume of our NaOH, and we do know the molarity of our NaOH, so we can use the molarity of the NaOH to convert from volume to moles of NaOH. So then what we can do is we start with the volume. So we have 12.54 milliliters over 1. And to use the molarity, which is moles of solute over liters of solution, we need to convert to liters. So let me specify that this is our NaOH solution. And so we're going to need to use the equality. So we have milliliters is equal to liters, some number of liters, some number of milliliters. I put the 1 always with the prefix, and then the prefix multiplier with the base unit. So milli is 10 to the negative 3. So there's my equality that I can use as a conversion factor. So milliliters is on the top, so I'm going to put 1 milliliter on the bottom. So 1 milliliter of my NaOH solution, and 10 to the negative 3 liters of my NaOH solution. So milliliters is going to cancel out, and now I have liters of my NaOH solution. So the next thing I'm going to do is now I can use the molarity, so 0.100 molar. So that means that 0.100 moles of NaOH is equal to 1 liter of the NaOH solution. So, since I have liters of NaOH solution on the top, then I'm going to put liters on the bottom. So 1 liter of NaOH solution goes on the bottom, and I'm going to put 0.100 moles. So 0.100 moles of NaOH on the top. So now the liters of NaOH solution cancel out. Now I have moles of NaOH. So now what I want is moles of the HCl. So now I can use my balanced equation to convert moles of NaOH to moles of HCl. And so it's a 1-to-1 ratio. So now I'm going to use my 1-to-1 ratio. So 1 mole, I have moles of NaOH, so 1 mole of NaOH goes on the bottom, 1 mole of HCl goes on top. Moles of NaOH cancel out. Now I have moles of my HCl. So now I can calculate the number of moles, and that's going to be 12.54. So I'm going to multiply across the top, divide by the bottom. I'm going to ignore the ones. So 12.54 times 1 times 10 to the negative 3 times 0.1. And then I have 1, so I'm going to now divide by the bottom. 1, 1, 1, 1. So it's just divided by 1. And so I get moles 0.001254. So 0.001254 moles of HCl. So now I have the moles of HCl. Okay, so moles of HCl now, and I also have the volume, but I need to get molarity. It's moles over volume in liters. So now I'm going to change that to liters. And so the way I do that is I use my milliliters to liters again. So I'm going to take 10 milliliters, use this as a conversion factor. So I have milliliters on the bottom. So 1 milliliter, this one. So I have 1 milliliter on the bottom and 10 to the negative 3 liters on top. Milliliters cancel out, and that's going to be 0.010 liters. and so of my HCl solution. And so to find molarity, all I do is I take the number of moles and I put it over the liters. So I have molarity of HCl is equal to 0.001254 divided by 0.010 liters, and this is moles of HCl. This is HCl solution, and then I calculate that out. And so here, so I take this and divide by 0.010 equals, and there the molarity is 0.1254 molar. And so that is the molarity. And now I have to check my I have to check my sig figs. And so since to get this number I had to multiply and divide, so I look at the numbers that are not exact. So my 1 milliliter to liter, that's exact, so I can ignore that. The 1-to-1 ratio, that's exact, so I ignore that. So the molarity I have is 3 sig figs, and the volume is 4, so the smallest number is 3. So I'm only allowed 3 sig figs, so the last sig fig is the 5 there. But now I'm going to continue that in my calculation. So I'm going to keep all the numbers, but for purposes of sig figs, I'm underlining the 5 to remind myself that when I'm thinking about the sig figs in my final answer, this only has 3 sig figs. So when I took this and I converted it, right? So when I converted, or when I took the volume and converted it, I didn't change the sig figs there. So that stays at 2 sig figs. This stays at 3, so when I divided it, the least number is 2. So that means I'm only allowed up to the 2. So then this becomes 0.13 molar for the HCl. So that is the molarity of the HCl. Okay. I hope this was good for you. I hoped you got a lot out of this, and if you like this video, please share the video and make a comment in the comment section. Subscribe to the channel and ring the notification bell. Also, I'm going to do another problem in my next video, so I'll see you next time.